All right, we are back in Cybermillion, episode 4. Let's get into it. Let's start the lab here. All right, so it's going to be Mkdir, Touch, MVCP, so kind of like file stuff, right? Commands. You will require some Linux commands more often than others. Making directories and creating, moving, copying, and deleting files are all commonplace. You'll likely be used to the GUI steps required to perform these tasks, but what about the Linux CLI? Alrighty. I like the GIFs, they're pretty good. Using Mkdir. We previously covered that we can navigate to a directory by using the cd command. The Mkdir directory name command can be used to create a new directory using the name you specify. The example GIF above shows you how you move, how you might use Mkdir. Okay. I don't know if this is necessary. Like, they should have like an interactive thing right in here, but all right. Gonna move on. Yeah, it's confusing. Using Mkdir, we've previously covered. I'm back into that. Okay. Create new file. Touch. Okay, so can we? All right, let's do this. Navigate to the changing things folder. Okay. Token. From inside the changing things folder, create a new folder called testing. All right. All right, let's learn about Touch. Using Touch. One of the easiest ways to create a new file is by using the touch command, touch file name. If the file does not exist, an empty file will be created in your current directory with that file name. If you touch an existing file, nothing will visibly happen. However, the last modified time of the file will be updated to the exact time you ran the command. Yeah, that's actually pretty good. So touch hello, right? Let's see the time. So we got 23:28. Now if I do it again, it's 23:28. If I now touch hello, it's 23:28. All right, because there's no second. I gotta wait till like. Let's wait a minute. Oh boy. All right, we'll get back to this. Touch by default will not add a file extension to your newly created file. Files with no extension are treated as any other file in Linux and can be edited with using the text editor. If you require a specific extension, you will need to include the extension when running the touch command. For example, touchfile.txt would create a new text file, whereas JPEG would create an image. Both files would, however, be empty. The above examples show how you might use touch to create a new file. All right, I think we're here again. So again, it's going to show 28. If I do touch hello, it's going to be 29, right? So it updates the file time, which is pretty good because you can actually, do we have nano here? Yeah, so testing at 7:29, okay. Let's test it at 7:30. Oh, we got to complete this thing. Okay, too much going on. All right, move to the new testing folder. Well, actually, let me do so again. 7:29. Touch hello. Cat hello. It's still going to show 7:29, but the time changed. So nothing changes inside the folder, inside the file. CD testing. Use touch command to create a new file. First file. All right. Pretty good. I like that. All right. It's kind of like capture the flag, you get a code. It's nice. Inside the testing folder, create an empty file called empty. Okay, touch empty. Let's copy that. Rename the first file to be called second file. What is the token? So we got to use the move command, right? So moving files. The move command is used to move files from one location to another. For example, entering the move command, that'll bring it back one directory, would move the file into the parent directory, right? Confusingly, the move command is also used to rename files. That is true, it is confusing. It will not only move files in directories, but also rename files in the same folder. If we wanted to rename a file, we could enter the command move my file new name rather than moving into a new location. The above example, right? So it is also possible to rename and move a file at the same time. For example, the command my file, new file would move it, right? All right, let's do this. So we got first file, rename first file to be called second file. Okay, first file, second file. Nice. Get a token here. All right. Copy the second file to a new file called third file. Okay. Oh, did we go over this? No, we're doing CP now. All right. Now you see how this is like, I feel like this is better because, or it would be better if it was like you had this, and then you had a terminal on the side. Like that would be the best scenario. All right, using CP. The CP command is used to copy files to a new file. You specify, unlike move, using a CP command will keep your original file. For example, running the command would create a new file, an exact copy of the original file, while leaving the original file intact and unedited. Now, the only thing is, let's try this out. So, CP, copy the second file to a new file called third file, right? I'll take the token, but I want to demonstrate something here about overwriting stuff. So if I do CP second file again, third file, it does that, right? Now, if I put a flag in there, it asks me to overwrite it because, like, it will automatically overwrite stuff. So you gotta be careful there. I mean, yes, we'll overwrite it. I wonder if I just press enter if it'll do that. See, now we gotta, okay, now we gotta test it out. Testing. And I'm using Control P to go down there. Okay, so now we're gonna, let's actually do this, cat third file. And now we're going to do this. I'll just press enter, I won't say yes. And now let's see what we get. So it didn't do it, right? Because if I do this and I press yes, and then I go like this, it's good. So that's good to know. All right. Delete the empty file that you created in question 4. Question 4. What the hell is question 4? What is the token you receive for deleting? All right, we got to learn RM right now, right? So let's do that. Deleting files. They got to put like a line here or something. Overall, I mean, this is pretty good. You learn stuff. Using RM. To remove files, you can use the RM command. The example above shows how you might use RM to simply delete a file. However, use with caution. Unlike most GUI-based systems where deleted files are temporarily moved to a trash or recycle bin folder, using the RM command on the Linux CLI will completely and permanently remove the file from the system. Deleting files using this method is irreversible without specialist knowledge. There's always a but. Hopefully they teach that here. So always double click double check you're deleting the right file. Yeah, RM by itself will ignore any directions it is given, as directories are required to be empty before they can be deleted on the command line. If given the R parameter, RM will remove everything from inside the directory, including all files and child directories, before finally removing parents. Yeah, that's good to know. That is good to know. So question 4, what was question 4? Inside the testing folder, create an empty file called empty. So now we're going to delete empty. That's gone. All right, very good. Navigate back to the changing things directory. Are we good here? Yeah, we're good. All right. Okay. What is the token you receive for deleting the folder? What folder? Oh, delete the testing folder. Okay. RMR, because there's stuff inside of it. Testing. Get that token. Get that token, guys. All right. And now we wait because it automatically changes. That part I don't like. All right. Lab feedback. We could. That's pretty good. I liked it. Okay. I feel like they should do like 1 out of 5 or something. I don't know. Next, let's do this. File permissions. How long did that take, and how long was it supposed to take? That's what I'm curious about. Let's see how long that was supposed to take. Command line. Let's see, changing things, 10 minutes. Yeah, all right. Okay, cool. Let's start the lab. File permissions. File permissions, 9 minutes. They got it to a science. Alrighty. And actually, we just went over this with Linux Journey, right? So permissions. Access to every file on Linux is controlled using file permissions. These permissions control who can perform certain actions on files on the Linux file system and are broken down into read, write, and execute. Let me see how. Yeah, okay. Actually, I didn't do this yet on this one. All right. For example, a user with read and execute permissions on a file would be able to read the file as well as execute it. However, this user would not be able to save any edits they make to the file, as they do not have write permission. Yeah, that's super important. Okay. Reading permissions. You may not have been aware, but you've already seen file permissions if you've completed the previous labs in the series. When running the lsla command, you're presented with a list of files in your current directory. One of the characteristics displayed in this list is the permissions of a file. Right, you got permissions here. Well, first it tells you the directory. Yeah, let's break it down. Okay, so first character in your permissions tells us that the file is actually a directory. If this character was a hyphen character, we know that it's a regular file. Let's just double check that. Yep, all right. RWX is the user's permission. Identify the permission of the user who owns the file. Or the owner, right? The owner of the file is identified by looking at the third column of the file list. So that's right here. In the above example, the user Linux owns the current directory, also known as dot, and the user root owns the parent directory, aka this. The permissions RWX tell us that the owners of these folders have read, write, and execute permissions. And that's actually the order that kind of needs to be remembered, RWX. Let me see here. So the second set of 3 characters, RWX above, identifies the permissions for users who are part of a specific group. In the above examples, the users in the Linux group, right here, have read and execute permissions on the current directory, and users of the group, the root group, have read and execute permissions. So like the user Linux has full permissions, but anybody in his group would only have those two. Finally, the last three characters identify the permissions for everyone else on the system. If the user isn't the owner of a file or part of the group that owns the file, which is here, these are the permissions that apply to that user. There's also something called ACLs, but yeah, it's not free here. Let's actually get back to this. What do we got here? So we got use the lsla command to list all the files in your current directory. Which of these files is word writable? lsla word writable. That means, well, so we are IML user, right? So this would be writable. This would be writable. That would be writable. So what are they asking here? Which of these files is world writable? They're asking anybody. Anybody, that's this. That's this. 2.txt. 2.txt. Let's see if we got that right. All right. Running the command chmod 777 would give a file permissions represented as read, write, execute for everybody. What would the permissions of a file be after running the command chmod 755? Is that being taught here? I feel like this is actually a little, it's good, but it might be a little too much. So the way it works is this would be read, write, execute, or that would be like the permissions, right? For, I'm sorry, actually this would be user, group, everybody, and then the number, so like 7 would be all of them, right? RWX, because it goes in binary, so it'll be like, you know, 1, 2, 4, and when you add those up, it equals 7. So, alrighty, let's get back into this. So, a user with write permissions on a file can change its permissions to enable to restrict access to it. Typically, the chmod is used to update permissions of a file or folder. Chmod command can change the permissions of a file based on the parameters you specify. You can either specify a numerical value, chmod 755, or if you're updating permissions for the current user based on the action you wish to perform, for example, chmod g. Let's do this. Chmod g. I don't see g here. I do not see g here. So that's interesting. Let's see. Chmod. I don't see g here as a form of. See, I never used that flag. Would add the executable permissions. Yeah, and this would remove it because it's got the negative. So going back to this though, I forget if it's like which one it is. I think that this would give the user everything. This would basically, it's a 1 and a 4, right? So it's going to be like read and execute. So you're not going to be able to write. And this is going to be read and execute because you're not going to be able to write. And the numbers add up because it's like, again, it's 1, 2, 4. So if you want to combine, I just don't remember if this was read and this was execute. So let's see. Let's actually test this out. First I'm gonna chmod would give a file permissions of a file B after running the. So let's do. What do we got? Do we have a file here? Yeah. Okay. LSLA chmod 711 2.txt LSLA Okay, so one is execute, right? So it'll be like one is execute, two is write, and four is read. So what we would get is RWX, RX, because it's 1 plus 4, and RX. Alrighty. Alright, what's next here? Special file permissions. Wow, this is actually more than I would think that they would add. And it might actually be, I don't know if it's more than this because I haven't done this yet, but I'm actually pretty impressed by how much they put in here. Okay, special file permissions. There are 3 special permissions that can be used to override some behaviors. Each has its own use case. Set user ID. When this special permission is applied, it forces that file to run as the file owner, not as the user who started the file. When reading file permissions, the set user ID bit can be seen as an S in place of the owner's execute permissions. All right, I had no idea about this actually, so this is pretty great to learn. Let's do this. SUID. Special permission. Chmod. I don't see the special permission. What's weird is it doesn't have the G in it. Actually, let's do this. G flag. Nothing here. All right. Very weird. Okay, set group ID. Essentially, this is the same as the SUID permission, only this is set at a group level, not a user level. As with SUID, this is a SH own. This is shown. I can't believe I just read that like that. I was thinking CH own. This is shown as an S character in place of the execute, but this time it's a group permission change. All right, very cool. So it forces the file to run as the file owner, or I guess it forces the file to run as a group owner. Interesting. Sticky bits. Wait, let's do. What 3-digit numbers would you use with the chmod command to set the permissions as RX? So we know that that's 5, right? WRX. Wait a minute. Yeah, RX, and then here would be R, so it's not R, so 1 plus 2 is 3. And then RW is 4 plus 2, which is 6. All right. Kind of confusing because you got to remember it, but yeah, anyway. Let's see what we got here. Sticky bit. When creating files and directories, permissions are inherited from the parent. There are times when it is necessary to create a file that cannot be deleted in a user's directory. Sticky bit allows this as it is a special mode, meaning only the owner of the file can delete it. It is denoted by a T at the end of the permissions. T. I did not know that either. That's pretty awesome. Okay. Chmod permissions file, change the permissions. So, but how do you do this? Like, how do you apply the thing here? Let's see, we've got that here. Modifying SUID. Just like regular permissions, there are 2 ways to modify SUID: symbolic or numerical way. Oh, okay. And what about the GID? permissions group. Numerical representation. I don't know. That's all right. I'll get into that, I guess, another time. For now, I guess we just got to know. So run the command lsla and read the permissions for for 5. So RW, right? What is the numerical representation of these permissions? So 4 plus 2 is 6, and then we got 4, 4. Run the command lsla, which file has a sticky bit set. So it looks like the execute is going to run as the user here for 6. I wonder if that has to do with the color of this here. Wait a minute. Run the command lsla, which file has the sticky bit set? What am I looking at? Oh, the sticky bit. Ah, shoot. I missed that one. All right, cool. Yep, definitely meant that one. All right, nice cat. I mean, this is good to know. Nobody can delete this but the user. Run the command lsla, which has the SUID bit. So that would be the 6. All right. Good lesson. Love it. All right. I'm excited to actually go through this one now. Let's try this out. Let's see what's going on next. That was good. Did that take 10 minutes? I don't know how long that took. Let's see how long that took. Can we see how long we spent on it? Probably not, right? All right, editing files. I think we'll do this one next, and then we'll call it editing files. All righty, we got another big wall of text. That's the one thing I don't like, but hey, text editors and the command line. When using the Linux command line, you will sometimes need to edit text files and save any changes. You may want to use the command line to find and edit a hidden file, as it is easier to do than trying to hunt for it through a GUI. The easiest way to create new empty files is by using touch command. Once your file has been created, you're likely going to want to edit it. At the command line, there are a variety of options that may be available to you. There are 2 common text editors used on the CLI, Nano, Vim. Oof, anybody using Emacs? Angry. All right, Nano is a small and friendly text editor and is commonly installed on Linux operating systems. Nano is considered a more user-friendly text editor compared to some of its more advanced counterparts. One advantage Nano has over its competitors is that the text editor provides several shortcuts to perform basic functions such as saving, quitting, justifying, and more. These shortcuts are listed at the bottom of the text editor when editing a file or using the control, and are used by pressing Control plus, the shortcut. Yeah, this is a pretty good, pretty solid editor. I like it. So, and it creates a file the second you let's do this. I don't have a file named nano test, right? So nano test creates that, and then I can do hello world, press Control S, exit, and then I can do cat nano, and I have that. So it's pretty good. I actually don't use Vim, but I just started out, and I plan to. And actually, one thing I was looking at is Vim Adventures, which I hear that you have to start paying after like the 3rd level, but yeah, this one looks pretty good. Like you could go, you know. Yippee! So, gonna do that at some point. All right. Vim is one of the oldest, most popular text editors belonging to the Linux family, and it is available across many different platforms and distributions. It began as an improved blah blah blah. Open a file with Vim uses the same syntax. Vim, right. Editor has two modes: command and insert. I thought it had like 4 modes. Opening a file launches you by default into command mode. In this mode, you can move the cursor, cut, copy, paste text. Yeah, there's like a meme about not being able to escape Vim. So I wonder if they're trying to trick you into that. You can switch to insert mode by entering I. Once this mode, any keystroke is good. Supports numerous options that can be displayed using the help arguments. All right. Oh, I like that. Vim's ability to open the file at a particular line number. That's awesome. Okay. So one thing I was thinking about is actually learning Vim Motions, not Vim Editor, but let's try this out. So use a text editor to open sample text. Is that in here? Nano sample text. What is the contents of this file? The answer is not case sensitive. Okay, my name is Batman. Using your open text editor, add the text, my real name is Bruce Wayne. My real name is Bruce Wayne. Okay, save, close. Got that. It's okay. Pretty easy. Using a text editor, create a new file and add the text hello world. Nano add text. Hello world. Now it's interesting that they tell us to save this file as its file name before, because when I wonder if you could just do nano. Yeah. Okay. Save. Right. Okay. That's why they did it. Gotcha. Alrighty. When using Vim, what key would you press to enter insert mode? That would be I. When using Nano, which key combination would you press to save changes? I just press Control S. That's actually kind of weird. I press Control S. How do you save otherwise? I have no idea. Hello world. Control C. Wait a minute. Cancel. Control O. Is it Control O? Wow. Okay. Control O, write out. Is that what that means? Save? That's interesting. Okay, cool. Please only modify the required. If you modify, update, or delete additional files, the lab may not perform as expected, and you may not receive the token. Wait a minute, I just did Control O. Okay. All right, I'm going to end this here. Let's skip this part. And yeah, should be done here.